In this video, we're doing Test 10, Section 5, numbers 8 to, what did I want to do, 12. Yeah, 8 to 12. And this starts on page 967. So let's go with the number 8. We're working through the mediums now. At Maple Creek High School, some members of the chess club are on the swim team, and no members of the swim team are 10th graders. Okay, so some chess club members are swim team, and no swim team are 10th graders. Okay. Which of the following must be true? So this is a kind of logic kind of question. So let's see what we can do. Let's pretty much just go right to the choices and see which one works. And the key here is must. Some of these could be true, but must they be true? That's the key. Let's look at A. No members of the chess club are 10th graders. Well, I suppose that could be true. Nothing in the rules here tells us that it could be true. I mean, nothing in the rules tells us here that it has to be false. However, does anything in the rules tell us that it must be true? No. So that's why we can get rid of A. That's what I meant before by this must is the key. B. Some members of the chess club are 10th graders. It looks like that cannot be true, because look what they say. They say some chess members are on the swim team, and no swim team are 10th graders. So at the very least, we know that some chess members are not on the swim, are not 10th graders, but we don't know anything more beyond that. So this can't prove it either way. No good. C. Some members of the chess club are not 10th graders. Now, aha. This must be true, and why is it this case? Well, look at what they tell us. They first tell us that some chess club members are on the swim team, okay? Then they tell us that no member of the swim team is a 10th grader. That means, since some chess members are swim team members, that therefore some chess members must not be in 10th grade by this connection. This is almost like an A equals B, B equals C, A equals C relationship going on here. You could also draw it with Venn diagrams. Have I done that before? I'm not sure. Let's imagine for a second that this is the number of chess teams, chess members. This is the number of swim members, right? So this is chess. This is swim. Here is the thing we're talking about where some chess club members are on the swim team, right? It's this little intersection here. Now you can imagine we need to figure out where the 10th graders goes. We could write it in many ways. We could say the 10th graders could be over here, right? So that there are no chess club members or swim team members in the 10th grade. Or we could write the chess club team here, right? Where we have some overlap but not total overlap. The thing we can't do is have this 10th grader overlap with this part of the Venn diagram. So that's why we know that at least some chess club members are not in the 10th grade for that very reason. So C is going to work. Let's just look at the last two. D. More 10th graders are on the swim team than are on the chess club. We have no idea about that. E. More 10th graders are on the chess club than are on the swim team. We don't know about that. So the answer here is going to be C. 9. If 3x plus n equals x plus 1, what is n in terms of x? So, a couple ways we can do this. First, they want to know what n is in terms of x, so that means solve for n. So we can just do it algebraically. We subtract 3x from both sides, we get 1. So x minus 3x is minus 2x, so 1 minus 2x, that's choice D, done. The other way we can do this is plug in a number for x and see what you get, because you want to know what n is in terms of x. You got a bunch of x's in the answer choices, so let's put in our own answer here. So let's do, 2. 3 times 2 plus n equals 2 plus 1. 6 plus n equals 3. N equals minus 3. So we would go to the choices and see which one equals minus 3, using our x as 2. So let's see. A is 8 plus 1, 9. No. B is 4 plus 1 is 5. No. C is 0. 2 minus 2 is 0. D is minus 3. Check. So D works, and E doesn't work. So D, again, is our answer. Two ways to do that one. Do whichever way you're comfortable with. 10. If k is a positive integer, let k box be defined as all the multiples of k. So all the multiples of k. All the numbers in which of the following sets are also in all three of the sets 2, 3, and 5. So they give us this. So how do we translate this? Well, this is just all the multiples of 2. So it'll just be 2, 4, 6, 8, forever. We also have 3, which will be all the multiples of 3. 3, 6, 9, 12, forever. And we also have all the multiples of 5. 5, 10, 15, 20, and so on. They want to know all the numbers in which of the following sets are also in all three of the sets 2, 3, and 5. So let's go through the choices. So let's look at 5. That would just be 5, 10, 15, 20, and so on. Now we want to know in which of the following choices here are all of these numbers contained in each one of these. Each one. Not just one of them, but each one. Well, we know we have a problem here because 5 is in 5, but it's not in 3 or 2. 10 is in 5, but it's not in 3 or 2, right? There's no 10 here. So we can get rid of A because it's not in all of them. Let's look at B. 6. 6, 12, 18, 24, so on. Well, I can tell you this right now. 18 is not in here, right? It's not in the 5. We go from 15 to 20, so that's no good. We can get rid of it immediately, and you'll see it doesn't even work with a lot of them. 6 is in these two, but not in this one. It's just not going to work. C. C is 10. So this is 10, 20, 30, 40, ... Well, 10, we look at 10. 10 is here, but it's not here, so we can get rid of this. We know it's going to be in 2, 6, 8, 10, but it's not in 3, so we can get rid of it immediately. And you can test out other numbers, and you're going to see they're not all going to be contained here. D, 21. Weird one. 21. 21, 20, or 42, 63, so on, 84. How about this one? Well, let's look at 21. We know 21's not going to be in this guy, because it's in 5, I should say, because it's 5, 10, 15, 20, 25, so there's no 21 here, so that's enough to get rid of D. And we can test out other ones, and we'll see that it's not going to work. So E, which is 60, better work. 60, 120, 180, and so on. Well, think about 5 for a minute. We're eventually going to have 60 in here, right? Because 5 times 12 is 60. For 3, we're eventually going to have 60 in here, because 3 times 20 is 60. And 2 times 30 is 60. So 60 is going to work. And in fact, 120 will work for all of them. 180 will work for all of them, and so on. Why is this the case? Well, the easiest reason to see that, reason why this is the case, is that 5 times 3 times 2 is 30, right? And 30 is going to be a part of all of these, and that's going to be why, essentially, it's going to work. Another reason is 5 and 3 and 2 all go into this. They're all equal. They're all divisible into 60. So the answer here is going to be E. Number 11. In the figure above, first not drawn to scale, so I'm going to draw this essentially how they draw it, but my picture and their picture may be wrong, so we have to go by what the problem says. And it's A, B, C, D, E, F, and O. In the figure above, ADB and CF intersect at point O. If the measure of AOB is 80, and CF bisects BOD, so CF bisects BOD, so that means this guy equals this guy. What is the measure of EOF? EOF. So we want to know this. Well, first thing, if you look at the picture, this is why it's important to recognize figure not drawn to scale. You might think that all of these angles are equal, and then you'll do something, be like, oh, okay, well, if they're all equal, then there are 1, 2, 3, 4, 5, 6 of them. 360 divided by 6 is 60, so the answer is 60. Well, no, because they're not all equal. First, because they're not going to be, but also because we really can't tell that for sure from the picture, because it says figure not drawn to scale. So let's instead work with our diagram and see what we can do. Well, we know this is going to be 80 because they're vertical angles. We also know that if we call this x, that this is going to be x because they're vertical angles, which means this is x since they're equal, which means this is x because he's a vertical angle to this guy. So we know the following things. We know that these two are 80, and we know that each one of these are equal. Well, we know there's 360 degrees in this circular shape, right? So first things first, we can subtract off these 80s, so minus 80 minus 80. We do that, we're going to get 200. That means there's 200 degrees left for these 4. Well, we just do 200 divided by 4, and that's 50. So each one of these guys is 50, so that's going to be choice B as your answer. Space here. 12. if k is a positive integer, what is the least value of k for which square root 5k over 3 is an integer? So we got to just plug in our k's here and the choices and see which one gives us an integer. So let's do a. A is 3, so it'll be rat 5 times 3 over 3, which would just be rat 5. That is not an integer, so a is no good. B, 5. Rat 5 times 5 over 3 is rat 25 over 3. That is also not an integer, no good. C, rat 5 times 15 over 3. That's going to be rat 75 over 3, which is rat 25. That is just going to be 5. That is an integer. We're done. We just want the least value of k, which in this case is 15. So C is going to be your answer. If you actually test them out, you'll see that E would also work. But it's 60. It's bigger than 15. So 15 is the least value here. So we go with C. And that's the final answer.